In this video, I will be illustrating how to construct a single polarized directional dual pan self-grounded bow tie antenna using commercially available tin. This is an extremely low cost antenna as the tin was acquired from a scrapyard. First, we will need to determine the dimensions of the antenna for the specific Wi-Fi application, meaning the two Wi-Fi bands. We need to cut out a stencil of the appropriate dimensions done by using frequency scaling based on an existing design. Once you have your dimensions, we need to determine the required extended angle that we need. In this case, we will be using an extended angle of 90 degrees as can be seen here. After cutting out the stencil from your raw piece of tin, you would end up with a piece like this. This piece of tin needs to be folded over so that the two flaps can be fed using a coaxial cable. In this demonstration, I'll be using a 50 ohm coaxial cable to feed the antenna. 3 holes would need to be drilled in the antenna in order to feed the coaxial cable. The first hole will have to go through the ground plane, the second through the bottom and under flap, and the third one on the upper flap. The diameter of each hole would be dependent on which cross section of the coaxial cable is going through this. The 50 ohm coaxial cable here in this demonstration would be fed through the bottom plane. It would have the outer braided conductor soldered to the bottom flap and have the inner conductor soldered to the upper flap. You should be very careful when soldering this to keep the spacing between these flaps to be less than 1/20th of a wavelength. Additionally, neither of the flaps should touch the ground plane to prevent shorting out the antenna. The holes drilled onto the upper flaps should be as close to the end as possible to minimize the overlap of the flaps, as this introduces a capacitive effect and would decrease the performance of the antenna. I will now be illustrating the efficiency of the antenna and its functionality by connecting the antenna to a router and testing on a 2.4 GHz band. Using the Wi-Fi analyzer tool, the signal strength in dBm is illustrated on the graph that can be viewed on the phone. As we can see, as we have moved, there was a definite null being introduced. As we keep moving around, we can see that the antenna is still not picked up. However, we can keep moving around and wait. Still within the region. As we can see, the antenna that the antenna connected to is much higher in signal strength. As we move around, we back to the same point with the null. As we can see, where we are right now is a null.